Nuclear power has been around for decades. How does it work? What is the current state, and what are the future prospects? Nuclear power stations work under the same principle as conventional plants, which is heating water to create pressurized steam that turns turbine blades to produce electricity. The heat source is energy emitted during nuclear fission reactions of the uranium fuel instead of coal combustion. In order to allow for sustained fission, however, enriched fuel with a high percentage of uranium-235, as well as moderators that lower the neutron energy and increase the probability of fusion occurring are required. But what does the public think? Is nuclear energy a hero or a villain?
The first thing you think about when you hear nuclear power?
Electricity. Renewable resource?
I don't think it's as bad as
I think negative connotations completely.
Do you think it's a bad thing, good thing? Do you think we should promote it in the UK or anywhere in the world?
I think in certain places you should promote it.
Well, obviously not about avoiding like a genetic catastrophe. I think we probably should promote it because we are using up what we already have.
Well, I don't know enough about it, but I've heard it works and it's pretty efficient.
Yes, it's a good thing. You don't think it's dangerous? What about the safety measurements taken? Do you think...
I believe everything has an element of danger. Coal-fired power stations, pollute in a different way. All these risks exist. It's a question of managing risk.
Opinions are divided. Let's look at the facts.
The current state of technology shows that energy generated from nuclear power has risen over the last 3 decades, with its success being attributed to the pressurized water reactor.
Let's now expand on this type of nuclear reactors. Firstly, pressurized water reactors mainly use nuclear fission to heat up pressurized water and extract this heat from it using turbines. Sizewell B is the only pressurized water reactor in the UK. It has been in operation since 1995, 7 years after its construction. It is operated by EDF and has a power capacity of 1198 megawatts. The plant capital cost is estimated to be around £2.3 billion, with running costs approximated to 8p per kilowatt hour.
We're now going to look at life cycle emissions from Sizewell B. The total greenhouse gas emissions have been calculated to be 6.04 grams of CO2 equivalent per kilowatt hour. In comparison, this is 68 times lower than the same value for natural gas power plants. This is due to the emissions being dominated by the construction, mining and milling phases alone, as no CO2 is produced during electricity generation. In addition, nitrogen oxides and sulfur oxides emissions are about a third lower than natural gas power plants.
Radioactive waste is the biggest drawback of nuclear technology. It is required to be stored under controlled conditions for 30 to 40 years before being permanently buried. Sizewell site has a 1,000-ton storage unit where used fuel from all over UK is stored. The storage ponds are currently almost full, and it's planned to transfer the waste to dry storage caskets, which consider safer and add to the storage capacity.
Incidences occurred in Sizewell B in the last 3 years have only been at level 1 on the 1 to 7 event intensity scale, indicating no impact on the safety of the public or workforce. Moreover, level 1 events show a gradual decrease in the last 3 years. As additional safety measures, EDF Energy has inaugurated an emergency response center near the station, which contains backup plant and control systems.
Future developments include new reactors being deployed worldwide and the push for more developments for fast neutron reactors and small nuclear power reactors.
Through the example of Sizewell, we can conclude that nuclear power is a viable and advantageous alternative energy that needs to be promoted. Thank you for watching.